Mishra, and in this video, I shall be giving you my teaching demo. The topic that I have chosen is projectile motion, and I'll very briefly talk about the basics of projectile motion in this small lecture. Okay, I'm really excited towards starting this lecture, and I would assume that you are my students, and that is how I will be going ahead with the video. So, hello, my dear students. I am Chetan Mishra. In today's lecture, we are going to start something called projectile motion. Okay, let's give the heading first. Projectile motion. All right. Okay, before going into those complicated formula, results, definitions, let's hold ourselves a bit and let us think why we need to learn this chapter. Once you understand the reason behind learning a chapter, the chapter becomes more interesting and it becomes more, tolerable if you if you say it that way. So let me start with an example. Do we all love Neeraj Chopra? Do we? We were extremely proud when he won the gold medal at the Olympics. We had seen that he had thrown the javelin. He had thrown it multiple times, but it was probably the second time when the javelin had got the maximum horizontal range. And that's how you win a gold medal, right? But I am more interested in the path that the javelin must have taken. Can you tell me what sort of path had the javelin taken? Assume that Neeraj had thrown the javelin from this point. The javelin would have gone like this, reached a maximum height, and then hit the ground somewhere like this. Okay? In this case, I am interested with the path that the javelin has taken. All right? Uh, let's take another example from sports only. Do we love cricket? I think most of us do, right? Don't we love when AB de Villiers used to hit a six? We did. We all loved watching him playing those 360-degree shots, right? But you must have seen, assume that he has hit a 100-meter six. And after he has hit a six, in the television, you must have seen something called a ball tracker, right? What happens? Ball tracker simply tracks the trajectory of the ball. Once again, you would see that the trajectory of the ball is somewhat similar to the trajectory of the javelin that Neeraj Chopra had thrown. And let me surprise you, you don't need an AB de Villiers or a Neeraj Chopra to showcase projectile motion. Even we people, we are good enough to experience projectile motion in real life. You want to see how? We must have thrown a ball, must have taken a ball and thrown it in the air. We must have thrown a stone somewhere, right? Let us say you're standing on the ground and throwing something like this. We can see a similar path being taken in this case also. Along with that, you can also throw an object from, let us say, the top of a building, and you can experience a similar sort of trajectory being taken. All right? So let me tell you, all of these motions come under the category of projectile motion. All right? Projectile motion is not something which is limited to the case of gravity. I'll give you a very general introduction and definition of projectile motion. But to understand how it is important and how it is present in our real life, I have taken these examples. I'm sure that you're feeling a bit interested at least in this chapter now. Are you? Good. All right. So we would be going to the real definition of projectile motion. All right. Projectile motion is a subset of 2D motion. What is 2D motion? 2D motion is motion in a plane whenever the entire motion can be captured in a particular plane or a piece of paper, if you put it that way, if the entire motion of the body can be kept in this particular plane, this plane can have any possible orientation. That is called a 2D motion, and projectile motion is a special case of 2D motion. Keep this in mind. What is projectile motion? A special case of 2D motion, right? If this is 2D motion, its special case would be projectile motion. So can I say that all projectile motions are 2D motions, but all 2D motions are not projectile motions? Any other example of 2D motion? Circular motion could be an example of 2D motion. All right, an ant moving randomly on a piece of paper, that is also a 2D motion, but surely not projectile motion. All right. Then comes the question of how to understand which motion would be projectile and which motion would be not. Okay, let me tell you. For a motion to be projectile, there are two conditions. You should be looking for two conditions in which a motion can be categorized as projectile motion. What are the conditions? Let me tell you. The conditions. The first condition is, this is very important. Always look for this first condition. If this first condition fails, we don't even need to look at the second condition. Are you willing to know what the first condition is? Yes. The first condition is very important. The first condition is acceleration must be constant. Acceleration of the body, which is undergoing projectile motion, acceleration must be constant. The acceleration cannot be a variable. All right. So we should be careful while studying projectile motions, because if you throw a body far away from the surface of the earth, you may have gravity as a variable, because gravity reduces as you move away from the surface. Okay, so in projectile motions, what we normally consider? We consider that the body is very close to the surface of the earth. All right? Okay, so in whatever condition, the first thing is that the acceleration should be constant. How are you keeping it a constant? That is none of our concern. But the acceleration of the body should be a constant, because this is the part of physics which is kinematics. We learn about the motion without knowing the reason behind it. So we don't know from where that acceleration is coming. But if that acceleration is there, it has to be constant. Mind you, acceleration is a vector quantity, which means the magnitude as well as the direction both should be constant. Is that making sense? Okay. And the second condition is that angle between velocity and acceleration shouldn't be 0 degree or 180. Hope that this is visible. It shouldn't be 0 degree or 180 degrees, which means at any instant, if you see, if the acceleration is in that direction, the velocity is in this direction, we need to consider this angle, theta, the angle between velocity and acceleration. We need to consider that this angle is not equal to 0 degree or 180 degree, which means velocity and acceleration should not be parallel or anti-parallel. Can you tell me what condition would that be? If the velocity and acceleration are parallel or anti-parallel? That is the condition for rectilinear motion, motion in a straight line, which we have learned already in the previous chapters. All right. So I hope that these two conditions are quite clear to you. Let us repeat. First, the first condition, the acceleration must be constant. Whatever the value is, 8, 10, 20, 100, 2000, whatever the value is, it has to be a constant. Make sense? And what is the second condition? The angle between acceleration and velocity is going to be anything but 0 or 180. It can't be, acceleration and velocity can't be parallel or anti-parallel. Make sense?